Some waves on Earth can only be gigantic. And to explain why this is, let's take a trip to Mullaghmore. We begin our journey in northwestern Ireland. This coastline is rugged, it's rocky, it's gorgeous, and most importantly, it is exposed to gigantic swells from the North Atlantic. Now, when these large swells begin to encounter the coastline, the seafloor bottom rapidly shoals. There is a shelf, and what that does is it creates a slab of a wave. Now, this is what I mean when I say slab. Remember that a wave only begins to break when it feels the friction of the seafloor underneath it. When it happens this quickly, the friction really causes it to just topple over on itself, and the result is an incredibly thick wave. Now, remember what I said earlier about some surf spots only being able to generate gigantic waves and nothing else? Let's talk about why that is. Now, remember what I said earlier about waves actually beginning to break. They break when they feel the friction of the seafloor underneath them, and this begins at about half of the wavelength of the actual swell. What this means is that greater wavelengths will break in deeper and deeper water. Smaller swell needs a shallower seafloor bottom to even begin to feel friction and begin to make a breaking wave. Some spots on Earth, such as Mullaghmore, break over a reef or a feature offshore. And if the swell is too small, it'll never even feel the reef and it won't form a wave. Most places we think of as big wave surfing locations, Mullaghmore, Nazare, Cortez Bank, they'll never be able to produce a small waist-high wave. No friction, no wave. Back to Mullaghmore proper, in order to produce these gigantic waves, you need to avoid this island shadow, and so you need northwest or southwest swell. And like I said before, in order for a wave to actually form, that swell needs to be big. Ireland, Mullaghmore, we tip our cap to you. A big, beautiful, scary wave that can only exist as a big, beautiful, scary wave.